Dear friends, today let us look into more about cardinal points, that is, locating the cardinal points in an optical system. And this is what we have come across in the previous session regarding cardinal points, principal points and planes, focal points and planes, and nodal points and planes, and also about the Cartesian sign conventions. To locate the principal points, looking at this diagram, the second principal point H2 P2, this point P2 on the principal axis lies at this distance from the lens L2, and that's what L2 P2 is equal to L2 P2 is equal to beta. I have mentioned it here from the lens L2. Now, in order to locate this, I will coin this term QF2. QF2 is equal to this P2F2 minus P2L2. That's nothing but F minus beta. F minus this minus beta is taken because this length is measured in the reverse direction. The light is incident in this direction. We are measuring this in other direction, in the reverse direction. Hence, it is taken minus here. This will be equal to F plus beta. In the previous class, in the previous session, we had defined this term QF2 like this. 1 by QF2 is equal to F2 plus F1 minus D whole divided by F2 into F1 minus D. But now I will rewrite like this: QF2 is equal to F2 into F1 minus D whole divided by F1 plus F2 minus D. Therefore, from these two equations, F plus beta is equal to this equation. Therefore, beta is equal to minus F. This is brought on right hand side. This will be equal to this. And on simplification, we get this equation. And therefore, beta is equal to minus F2 D divided by F2 plus F1 minus D. In the previous class, in the previous session, from equation 6, F1 plus F2 minus D is equal to F2 into F1 by F. Therefore, on substituting this in this equation, we get this beta is equal to minus F into D divided by F1. That means this point P2 lies at this distance from the lens L2. Similarly, for the position of the first principal point, this lies at this distance. Alpha is equal to, following the same principles, if we derive the same thing, then alpha will be equal to F into D by F1. And since this is measured along the incident light, then it is taken positive here. Alpha is equal to F into D by F2. Then, to locate the second focal point here, from the same diagram, L2F2 is equal to P2F2 minus P2L2 here, F minus beta. This is nothing but, this will be equal to plus F plus beta. Substituting this beta, we get this. Therefore, on simplification, L2F2 is equal to F into 1 minus D by F1. That means this focal point lies at this distance F into 1 minus D by F1 distance from the lens L2. Similarly, positioning this first focal point is like this: L1 F1. This L1 F1 is equal to F1 P1 minus L1 P1. This is equal to minus F. This is measured in the reverse direction. Therefore, minus F of this L1 F1, L1 P1. This is equal to minus F plus alpha. On substituting the value of alpha here, we get this L1 F1. That is, this is at this distance F into 1 minus D by F2 distance from the lens L1 in the opposite direction. Therefore, L1 F1 is equal to minus F into 1 minus D by F2. And locating these first and second nodal points, since the medium of incidence and medium of emergence, both the medium are same, hence the nodal points will coincide with the principal points. Therefore, n1 is equal to f into d by f2, and n2 is equal to minus f in n2d divided by f1. Yes, this is what we have discussed in the session. That is location of all the cardinal points, first and second principal points, first and second focal points, and the first and second nodal points. And these are the books referred for this content. And thank you for watching this.